I'm Jonathan and welcome to the Business of Software. This is video 2 of a small series on designing for the future. In part 1 I discussed some new terminologies that I'm introducing basically to deal with this kind of thought that we have to go through surrounding change. The quick summary is that, let me put the slide there for us. The quick summary is that complexity and change always increases, and that it's no longer acceptable to say that everything changes. We have to start breaking that apart, and the way in which I feel is a good sort of next step for us would be to look at that statement and break it apart into 4 things, and that is change rate, and we'll start with that. Change rate is when you say everything changes, everything does change, but it changes at its own rate, at its own pace, and you can see that in how often you rename the database, for example, or versus how often you rename a table in the database, versus how often you change one line of code somewhere, right, in a function like to uppercase or something like that. So you can actually take each kind of function and each kind of thing, and you could look at it and say, perhaps not put an exact number on it, but perhaps you could say that this is more likely to change more frequently than this, right? This has a greater frequency than this, and this one has a great frequency than that, and so on. And you could order that if you understood or played around with the change rate of certain items. The second is the change gradient, and to understand that we have to say that when we're going to conduct a change, we have to look at the system as moving from state A to B. Right, so there's a change, a phase transition, and that line that you can draw between A and B is not a straight line. It's not horizontal, at least. That line has a curve or a gradient, and the change gradient represents the difficulty as a system increases and complexity and change increases as we do more in a system, that line is going to increase in difficulty. That line, that the ability to make that change will change, right? So that change is changing. And I've coined the term change gradient to represent the fact that it does increase in difficulty. But it's not the same as complexity, because complexity is something that you look at a piece of code and you say, well, how difficult is it to change this to that? And that complexity is based on various things that we have placed in the code, maybe some things that we have used to deal with complexity. We've tried to make it simpler in this way or that way. There's a learning curve. There's all sorts of things. And the complexity to conduct that change is also not a flat line between state A and B. It is also a gradient. So complexity, it's no longer acceptable to say, well, that's complicated. What we have to do is say, okay, so there are these things involved with the change. These things have a change gradient. This is the complexity of A to B. However, if we delay it, the complexity increases, and we can now look at the problem using these 4 terms to better understand it. So these terms, on the first level of thinking, it's purely to give you some terms or some heuristic for understanding what to think about when you're trying to delay something. It is inevitable for somebody to say, can we do this now? And there's this thing, this sort of pressure perhaps, and this thing where we say, maybe we can hold this off, maybe we can do that later, maybe we can do that next quarter, and so on. But in doing that, we have to understand that that delay, everything increases. And perhaps in an architectural design record, we could actually list the change gradient as it stands and have a formulation for determining that. More on this in later episode. Okay, so now I'm going to move on, and I'm going to move to the 3 laws of software design. what I tried to do here is go back all the way to what I could think of to be the starting point, the almost the first principles, or what I think would be the most important thing to consider, to understand what is involved with design, what is involved with architecture, what are those things, how should we think about it? And I came up with these 3 laws. So the first law is the humble box, and the reason why it deserves first law status is that we pull out a piece of paper, we use an app, we draw a humble box, we say that box represents X, that box represents the user or an order, and we can draw a box within a box, and we can say, well, that's the boundary, and there are a number of boxes inside here. And if you think of it from even set theory sort of point of view, you can see, well, we're drawing 5 boxes, there they are, that represent cups, they are a set of cups. And the box, the humble box, is our go-to go-to thing, and I'm not sure exactly, I haven't looked in yet how this box has come into our consciousness, how we do that, but it's pretty straightforward, and today anyhow, and people draw boxes. We have variations of that box. We can draw the line in sort of a dotted line form, and it could be representing a boundary. We can draw that box, maybe the border is a bit thicker than another border, a different color. We experiment a lot with this. If you think of the humble box, how abstract you can use this as well is that the box represents a card with some stuff written on it, and we put that on the board. And so the humble box is pride, right? Foremost thing that we use. So I thought it deserves the first spot. The second is the line. So when we're drawing a box and we have a set and we draw that, well, the next level of abstraction is to create a relationship between these things. And so that box is related to that box. We draw a line between them. We have a box within a box, and that box draws a line to something else. We can draw nodes and edges, right? So now we've got networks and graphs. So the humble line and box together pretty much do what we think it does. It pretty much builds systems. This is what we do. Now, the line is also representative of coupling because, right, this is what we do. We couple this to that, and that makes a system. And there's hierarchy, and there's connections, and there's process and flow. So process, you draw a line, you can draw a box overlaid on that line at one point, and you draw another. Now you've got some kind of flow, some kind of pipeline, some kind of transition, some kind of constraint or filter on that line. And we can represent that with a box and a line. So lines and boxes are extremely important for how we draw and how we think and how we utilize them for abstract thinking or abstract thoughts onto paper. The third thing, the third law, represents an iterative cycle, and the tick represents the checklist. So this is an iterative process that we apply, and we can do this in many ways. We can apply it while we're drawing. We can say, here's a box, here's a line. Oh, I don't need the box anymore. We have a checklist on the side, be ethical, and you go, oh, that box isn't a very ethical thing to do, and you can delete it, right? And by the way, if I go back to the line, you'll see that I forgot to mention it's a subtraction. And in fact, that's such an important part of it. I'm surprised I forgot to mention that. I just want to go through that now. Part of the second law, that subtraction, is that when you're drawing the boxes and the relationships, it's not good enough to continue drawing boxes and lines. You have to have a process of deletion. You have to say, how do I make this simpler? Do I need this? Do I need that? And so the line also represents subtraction. So when you're doing your checklist, and you're looking at constraints, dynamic forces, checklists, and regulations, you are considering removing or approving and asserting that your boxes and your lines are correct for whatever reason. Those reasons are becoming more and more abstract. A constraint might be, does this box connect to that box? Is there a line between this? Let me check my constraint. No, there isn't. Let me remove the line. It might be as simple as that, all the way through to a checklist from an ethical standpoint. Right? It could be something about budget or time. It could be a much more abstract concept that you're then applying to the humble box and humble line. So what I'm going to do is I'm going to go through these four things. I just want to check the time. Okay, so I don't want these to go on for too long. So the feedback loop is an iterative cycle that we can do, that we can share with others, and others can be part of this. Early on in a system's development, this tends to be a positive feedback loop, opposed to a negative feedback loop. But nevertheless, this feedback loop is in our heads or collectively in a team, and it feeds into our boxes and our lines. So we're going to go through constraints, and what I've tried to do here is give you some kind of acronym to remember and to think about. So the acronym here is AMMERSE. I actually wanted it to be EMMERSE, but yeah, it didn't make sense. It would be too confusing. So to simplify, I kept it as A. The idea here is that the constraints are divided into 7 weights. And these weights, this mnemonic, heuristic kind of weighting system, allows you to think about fundamental constraints. And I've included project management like things and software development like things because constraints are not purely technical, they're also coming from the business domain. So if I go through these quickly in a very quick explanation, because it's going to be covered quite well in a future video. Agile is having code that is agile in nature. You can go in and you can modify it quite easily. You can strip it apart and change it, and it's quite agile. And we're really talking a design time kind of scenario. You can pull the code out and you can say, let me pull this apart. Oh, that was easy. Right? You haven't broken anything. It's very good to have agile code. You want code that can evolve and be malleable, right? So you can change it and move it around. Minimal is a weight that is always reminding you to say, look, I cannot build something incredibly complicated right now. I need to keep it minimal, and it's always weighing you down to say, is this minimal? Is this minimal? So along with saying that, is this code agile? Can I do something with it? Maybe there's dependency injection and therefore it's now agile. You have this minimal constraint, which is saying maybe dependency injection or maybe having containers and some sort of elaborate version of that is not really what we're looking for now. And so there's this fundamental pull between these two, and that's why I've called them weights or constraints. Maintainable makes sense. We want maintainable code. We want code that is easily maintainable and readable and all those other great principles that people talk about. Environmental may be a little more difficult to understand, but the idea is quite simple. Environmental means that when you design something within an architecture or a model, that yours plays ball, right? So that your code is in the environment and it behaves according to that environment. If you build code that was maybe some code was developed by someone else in a certain style and you come in to edit, you should remain in that style. If that class does a certain thing in a certain way, it has a form of encapsulation or some way of coupling, and there's an architectural rule there that you maintain the environment. You maintain the exact nature that is there already. We don't bring an alien species and drop it into the system. Reachable is that we should design our things so that they are reachable within a time constraint. They are reachable within a budget. It's no good to design something and then we can't implement it, or we design something that is not reachable, you know, in this year. All right, this was the constraint. We had to reach this goal somehow, and so there's a trade-off between reaching to some kind of goal, and that goal could be time, it could be budget, and so on, and we have to consider that. So we've got minimal and agile and maintainable, environmental and reachable, all kind of tugging at each other because we need to solve this problem. But how we solve a problem, that those constraints all play against each other. And by the way, it's not just solving a problem. Now there is also an element of state A and B in terms of how do I solve a problem now that remains a robust solution for later. There are ways that we can, you know, patch something and say that's a solution, it's done, it was reachable, it was minimal, I did it. But however, it's not a long-term solution, it's not a long-term solve, so therefore I have to do more work later. And so solving is not just solving for now, it's part of this paradigm of solving for the future. Extensible is kind of agile code in a way. However, it's more runtime rather than design time. So agile code, we can go in there, we can add a new class, it's white box, we can modify something quite easily, recompile and ship, and that's good agile code. Extensible would be that we don't do that, we snap on a plugin. We build something that we can then deploy without touching the core of that system. So extensible code, think of it as agile code that has been done in a configurable, extensible way. And these 7 principles weigh on each other. Now, while we're doing this, we're going to go back to how change, complexity, and the gradients fit into this, right? So while we're trying to work out what these constraints are and how we should design something, we have to consider change, complexity, and the gradients of those as we go with time. So this is something like when we solve, we're solving for the long term. We pay attention to the gradient. When we build it minimally, we say, well, it's minimal now, but what is it going to change to be later? Perhaps minimal is, it's too minimal for what we need at a later point in time because of the change and complexity gradient, because it deals with these things and the change rate is high. So you can see how the dynamic forces are playing into the weight system, amplifying a particular weight. So if we want to maintain a minimal system, but we need a change gradient and a complexity gradient for workflow items that pushes us towards, let's say, you know, a configurable type of workflow, we now have an understanding of why it is better to design the plugin system for the workflow today rather than later. We can measure the change gradient in some way to ascertain whether it's a good decision now or whether it should be delayed later. So the feedback loop, this is another checklist, and it's called Surface. And Surface is another mnemonic just to make it play off in the brain more easily, and that is we want to make our you know, our designs simple. So we have a checklist that says, is it simple? That's easy. Is it useful? Okay, tick off that box, it's useful. Robust, okay, so robust, that has a meaning. We can get into all of these at another time. Robust, tick it off. Does it have functional aesthetic quality? Is it complete? And is it ethical? And we have this checklist, a very quick surface, and it's not proclaiming to be the only checklists. We need to build our own, and we need to understand. Surface is there to make you realize that when a design pops up, it's immersed, and when it pops up to the surface, that's the idea here, that at least you've got your acronym to go and tick off some basic things. Regulations. So regulations, we've got a brace for it. So we've got the brace mnemonic. And it's the same kind of idea. We need to pay attention to regulations. This is an increasingly important thing to do as a professional. We do not have, a bar association or some kind of committee for checking our qualifications, how good we are, or checking our code, checking how robust it is, checking whether it damages society or not. We don't have those things. If you think of it as AI, we don't have systems. Anyone from any country can develop a teddy bear and roll it out for kids, and there it has a microphone, and there it does some stuff, and there's no one to wrap them on the knuckles, and there's no one to prevent them from doing that. There are various things and things growing and all of that, but I think it's part of our accountability. Right, it's part of our professional code. So brace, the beneficence, is it benevolent? Is it something that is going to aid and help people more than the opposite? We have a responsibility to do things. Perhaps it's not great to hide behind a terms and conditions or some kind of non-warranty anymore. Perhaps that's something we need to think about. Are we accountable for what we do? Do we have a method of command and control? Can we go into the system and say, now you can't do this, now you should be doing that, and control that system? If regulations come in and say, your system is outputting something that is damaging, can you go in and command and control immediately and stop that? I mean, that is part of our regulatory responsibility. And also from an AI point of view, but in other systems as well, is it explainable? Can we explain what we have done and what the inputs and outputs are, and be somehow accountable for that? Okay, so I'm going to end it there. I'm just going to explain that I also have a very rough kind of idea of time boxes, immediate, short, medium, and long. Immediate, short, medium, long, and these are current, quarter, delay of 1 quarter, and so on. And the only reason why I've done these time boxes is just to kind of put states into perspective. It's quite arbitrary, if it's every month, if it's every 3 iterations, but we do need to understand what the time boxes are, right? What kind of period of time matters to our context? Are we a very, very quick daily deployed system, right? Micro commits and so on. Our time box is a week, okay, or our time box is 2 weeks. That's fine, but now you have a word. Immediate means that, short means that, or you can come up with your own terms. But you have a way of saying that our change gradient over the medium term or our change gradient over the long term is X. We shouldn't do this in the short term. We should delay it till the medium term. It's very, very important for all developers who are designing as they go and being part of the emerging design that's occurring to play their part. It's good for managers to understand what developers are thinking. It's good for vision. AMMERSE, brace, surface, if we all understand the levels of which we operate in, we understand that we don't solve problems in the long term today. We do, however, solve short-term problems today. We do solve immediate problems with solving design of a change gradient of X. Highlight if a change gradient is greater than that value, because we need to consider it. So that's video 2. What I'm trying to explain here is the laws and regulations and constraints and trade-offs, and put some terminology on it, put some mnemonics on it to help us think in everyday development and management within a system. So I'll end it there and just leave you with a couple of slides. Until next time. Thank you for watching.